In this video, I want to take the skills and ideas that we've learned the last couple of lessons and put them together in order to solve a problem. So the problem that we're going to discuss today is, and I think I called it cool last time. I don't know if you guys think it's really cool, but we're going to use Python to code in to turn these letters math with a space and then rocks, math rocks, of course, into a simple encoding that just adds 4 to the position in the alphabet. For example, wherever you see an A, put a 5. Wherever you see a B, put a 6. Obviously, there's no B in there, but we want to code this for any code that I put in, right? So I want to be able to do this for any set of letters that we put in. Before we do that, let's talk about a new IPO chart symbol. And as you can see, this one is the loop, right? So I probably have needed to introduce this one maybe last time, but the way that it's done, the way that you write it out, and you'll see it here in a second, it's a little different in Python because most programming languages use indexes, and so it would be like I equals the 1 or 0 or whatever, and then you would do a test in here. So this is the test, right? So in the middle. And then this is the increment, like how are you incrementing from one step to the next in order to get, so this test is no longer, you can get out of the loop. So that's how it's done. And I've implemented this in a way that I'm able to describe it in Python. Okay, so remember the oval was the start. And what the first thing that we want to do is we're going to bring in a couple lists that allow us to code like an A is equal to a 5. And so I've written them over here. You can see right here that A is equal to a 5, a B is equal to a 6. So if you have the letter A and you find out what the index is of A in alpha, well, then you can just take that index and then grab the number out of the alpha underscore num. So those are the naming conventions. That's just what I used. And so what I'm doing is I'm creating those lists, and we'll do that here in a second in Python. I want to roll over to Python here very quickly because I want to spend most of my time over there. So I'm just going to run through this real quick. Word, so we got to give it what the word is, and I put a little underscore here to represent the fact that it's a space. And then we got to initialize the code because that's what I want my output to be, is the code. And so this is what the for loop looks like. So again, the initialization is W is equal to the first letter in word. As long as W is in word, that's our test. Then we're going to keep doing this list, and then we're going to go to the next character as kind of our increment. So you come down here, so go to your first letter, W. We want to find the index in W and alpha. Call that IDX. Again, that's the letters that I use in order whenever I index into a list. And then find the number. So you got to go now to the num alpha and find that particular letter, the index or the number that's associated with that letter. That comes out as an integer, and I want to turn it into a string so that I can come down here and then add those two together. So you can see we initialize it to nothing. This over here is really not even a space. So I'm going to take that nothing and then add the string, the first string num, and then a space, and then it's going to come back up. It's going to check to see if our test is complete, and since it's not, we're going to go to the second letter, and then we'll do everything that we just did in the second letter. And then again, you just kind of keep coming up here, check to see if this is true. As soon as W is no longer in word, then it breaks out of the loop and then comes down and then outputs code. Okay. So that's the IPO flow chart for this particular algorithm. And so let's take this thing and program it in Python. So I'm going to come over here. So I'm going to use Spider again. All right. And then I just went ahead and put this up here so you guys don't have to watch me type this in. So if you set alpha equal to this list of all of these characters, then what it'll do is it'll create. And so I printed it, so you can see it down here printed. So it gives you a list of character A, character B, and so on and so forth. And then I said, all right, well, I'm going to create this. So range, start is 1, stop is 27. And then I'm just going to add 4 to each one. So again, this is list comprehension for numbers from 1 to 27. I'm adding 4 to each one of them. Hit F9, and you can see that it's the numbers. So it's 0, is there, 0 is the A, and it's lining up the way that we want it to line up. So that the 0th one has the 5 in it, the 1th one has the 6th, and so on and so forth, right? So it's lined up to what we want it to look like, and then I printed it. Okay, so let's go through maybe something that we haven't talked about yet, this idea of zip. Maybe I did talk about it, but let's just see why zip is pretty cool. So I'm going to have letter encode in zip. So what does zip do? Zip puts these two together. So it's going to create this, it's going to put these two lists together so I can access them basically at the same time. So zip alpha, comma, alpha underscore num. And maybe we just want to print. So let's print it out. We'll do an F string again. So F, we'll get the letter associated with alpha. And let's see, maybe code. To end our F string. So let's just print this alpha num. So apparently I did the other way around. It's num alpha. Num underscore alpha. So you remember these things are pretty important. So let's highlight those, print F9. And then what did it do here? Looks like it printed off the entire, oh, let's see, alpha. So letter, so I did the entire list every single time. So just in case you didn't think that Python's going to do exactly what you tell it to do, so instead of putting letter in, I put the entire list. And so it's giving you the entire list and then the code for it. So that's not helpful. Let's put in the letter and the code. Let's try this again. All right, so now what you see is for the letter A, you got a 5. For the letter B, you got a 6, and you can kind of see all of the encoding that we're doing. Blank space has a 31. Now, I would just point this out because I don't think I talked about this before, but if I wanted, so later on we're going to do classes and objects, and we're going to build these methods ourselves, but there's this representation method. So if I want to make the string, what it's the not the print out of it, that's the string method, but there's a representation method. I can run the exclamation R on here, and all that's going to do is add a little quotation marks for you. So I think it's going to be single quotation marks. All right, so the only thing that lets us do is see the fact that that's actually a space there, and the fact that these are, you know, strings, if you will, right? So you could have probably figured that out just by looking at the code, but that's what it's going to do. Another way to do the same thing is, or not necessarily the same thing, but if I wanted to increment through, I could also do the enumerate. I won't do that right now. I think this is fine. All right, so the next step that we want to do is we're going to bring in, so let me come back over here. And so we've got alpha, we've got num alpha. I got to bring in, so we got to bring in word. Let me show you how to comment this out. So I don't need this anymore. I was just looking at it. So if you press Control, if you highlight however many of these things you want to do and highlight and press Control 1, it comments it out. So now this won't run when I press the green button up here. Word is equal to math rocks. So math rocks. The word that we want to encode, I'm going to initialize code just like it says that we're going to do over here. So I'm done there. I can move over. And then we're going to have some kind of for loop here. So what does our for loop look like? So for W in Word. Python takes care of all of the other things, right? So for W in Word, we want to, well, let's print W first. Let's find the index. So again, I'm not sure if we've talked about this one yet either, but it's the dot index method. So what the dot index method does is if I give it a letter, like for example, whatever W is, in this case, the first time it goes through, it's M. So what it's going to do, it's going to say, tell me what the index is of M in this list. So like for example, if it's for A, if there's the second letter coming through, and this were an A in here, it would return 0. So IDX would be equal to 0. For an M, you would have to step through it. So I don't have it written out anywhere. Let's see, H would be, let's see, did I write out H over here? No, I just got the D. So D would be the 0, 1, 2, 3. So it would be the index 3 for a D. We don't have a D over here, so we're not going to really worry about it. But so that's what that method is doing, is it's returning the index, the number, the 0, 1, 2, 3, 4, the place in that particular list. So that's what index does, and we can print IDX. Let's see, and then maybe we're going to print string. So I'm going to turn string into a code. So it would be num underscore alpha of IDX. So what we're doing is we're using go find the place in alpha and then take that same place and find the number that's associated with that one. So let's see what happens here. All right, so let's go to the one that we know. M is 12, code is 17, A is 0, code is 5, and that's correct. We know about that one. And H was 7 is the index. Oh, and it's just adding 5. So that's all you're doing is adding 5 to the index. So that's good. So it looks like it's working. And what we want to do now is we want to go back and just go ahead and let's go ahead and create it. Right. So I know I haven't used code yet. I haven't used this thing that we initialized, and I don't need to print W anymore. I kind of know what's going on there. I know what IDX is doing. Right. So I know that's going to be the index. So I don't need to print that one anymore. And then let's see. I want to use that. So I'm going to set that equal to some other variable. We'll call it num because it's a number when it comes out. It's a number that's got a string on it, or that's converted into a string. And then we just do code is plus equals. Remember, code equals code plus whatever it is I put after this thing. And I want this to be num. And then I'm going to add a space because I want a space between each one of these suckers. If you didn't add the space, you could run it and see what happens, and it'll probably give you a bunch of numbers all stacked up right next to each other. So let's find out what happens. Control Enter, and so it looks like 17, 5, 24, 12, 31. So if you were sending this code to someone, it would look like this. That's the code would be there, and then hopefully only your other person would know how to break the code. In other words, to add 4 to each one of the spaces. Again, this isn't a great encryption problem. This is just something that we can do very quickly with the skills that we already know how to do. And in class, I'll probably ask you how to decode it, right? So that's the big deal there. Is we will either work that in class, or I'll get you guys just to do it and show me what you got. All right, that's all I got. Oh, I apologize. I do have one more thing. So remember the equal operator, right? The assignment operator. So this is, so I'll put it in print. So the assignment operator. All right, so there's other operators that we've talked about. This is the exponential operator, exponentiation operator. This one is the one that we haven't talked about that I want to cover real quick. It has to deal with the while loops, and it's the double equal to, the not equal to, here, let me put a comma in between these. The not, so this is these two, or are these two things equal to each other? Are these two things, or is this one not equal to that one? If it's greater than or equal to, if it's, I'm sorry, less than. If it's less than or equal to, if it's less than, if it's greater than or equal to, if it's greater than, I mean, all of these are Boolean operators, and all they're going to return is, so they return either a 0 or a 1, or a false. In Python it's a lowercase, and in R it's an uppercase false, but in Python it's just lowercase. So false is equal to 0, and really I say right now that true is equal to 1, but Python will interpret any number not equal to 0 as true. So if you had 200 in there and you're trying to see it is 200, then if you're trying to do some kind of while loop and all you're using is a number instead of a Boolean, if that number is equal to 0 is the only time when that's going to be evaluated as false. So if you have a while loop and you're counting down from 200, it'll just keep going until it's equal to 0. Here, let's do that real quick. So while r parent r, set r equal to 10. And remember, when you get in a while loop, you got to do something to make it. So r minus equals 1. So let's find out what happens. I think that's what I want to see. Yep, there you go. So while r, when it got to 0, right? So this thing went to 0, it didn't get into here, right? So it goes numbers from 10 down to 1. Okay, that's all I got. Make sure that you read the Jupyter notebooks and do the quizzes.